Hello once again, dear children. We'll be looking at the topic of chemical coordination, just to make it clear for you so that, great, chemical coordination. Okay, and as this is a topic that just requires you to know about the hormones and the functions and then be able to apply your knowledge, I thought, let me just do this section using the questions, but at the same time teaching you how to answer the questions and doing theory associated with it. Very importantly, my darlings, I will be going through various mnemonics by which you remember each of these glands and the hormones that they produce. Let's put the labels for 1, 2, 3, and 4 first, before we look at the hormones that are produced by each of these glands and the function of each of these hormones. Functions. I'm giving you 30 seconds to try and find out what each of these glands are. You can refer to your textbook or the notes given to you by your teachers. At least you'll be practicing. Okay, let's begin. Did you get it right? First one, pituitary gland. I just put G. Pituitary gland, known as the master gland of the body, as it produces many hormones that influence all the other glands. By the way, in chemical coordination, the type of gland that we are discussing are known as endocrine glands. Isn't that so, my darlings? Because endocrine glands release their secretions. Oh, here goes my fantastic spelling. Release their secretions directly into the blood. So these secretions travel through the blood to reach what is known as a target organ, and the target organ will provide an appropriate response. Chemical coordination as compared to nervous coordination is much slower. Are you with me, my darlings? So because you are now, the hormones are traveling through the blood. With nervous coordination, the impulses travel through nerve fibers. So that's your pituitary gland, followed by this gland here, which lies in your neck area, known as your, yes, you got it right, thyroid gland. And then this leaf-shaped one, and I know if you're Indian, then you know somebody in your family having a problem with this one, because Indians are more predisposed to diabetes. So diabetes is because there's a malfunctioning there. And then, my darlings, you get this last one. Did you get this right? Adrenal gland. The adrenal lies on top of the kidney. The adjective for kidney is renal. Adrenal means I'm lying on top of the kidney. Please, it's got nothing to do with the functioning of the kidney. So let's look at the hormones produced by each of these glands. Of course, babies, there are other endocrine glands. And the reason why they're not mentioning them is because you've done them when you've done reproduction. That's your testes, that produces testosterone, and your ovaries that produces estrogen and progesterone. Of course, you got to know that as well. And thank God that falls in paper 1 as well. So it's like learning it for reproduction and knowing it for chemical coordination. How do we remember the hormones produced by the pituitary gland? I teach children to remember it as 4 H's and a P. 4 H's and a P. What on earth does it stand for? What are the 4 H's then, my darling? The 4 H's are, yes, FSH, let's put it down in caps. FSH, You've already come across this, the follicle stimulating hormone, which stimulates the development of the follicle in the ovaries and the maturation of the ovum in the ovaries. Then you get LH, which brings on ovulation and converts your mature Graafian follicle into a corpus luteum. Then you get TSH. This is a new one for you, my darling, standing for thyroid stimulating hormone. So thyroid stimulating hormone means the hormone produced here is going to influence your thyroid gland. That's why it's called thyroid stimulating hormone. You don't have to be a rocket scientist to know that. And then you've got GH. Yeah, this is your growth hormone, which brings about the growth of your skeleton, that's your bones and your muscles. Of course, if you have a shortage of it, you'll be a dwarf. And if you have too much, you'll be a giant. So before I go any further, let me deal with the relationship between that gland, which is your pituitary, and that gland, which is your thyroid. To be able to deal with it, let's go through which hormone is produced by the thyroid gland, and the hormone is called thyroxine. Easy, darlings, because let me put this in small letters for you, baby, so it'll be able to fit in. Do I know how to get the small letters right now? Maybe not. Let me just make this a little bigger. There we go. So thyroid gland produces the hormone called thyroxine. Very important hormone. In fact, every hormone is important. But thyroxine is important because it does something that is vital for your body, in that it regulates your metabolic rate. Now, whenever children come across the term metabolic rate, they become a bit flustered. As far as you're concerned this year, take your metabolic rate to be your respiratory rate. That means the rate at which respiration is occurring. So if it regulates your metabolic rate, it stands to reason that if you have less thyroxine in your blood, your entire metabolic rate will drop. In other words, your respiratory rate will drop. So if your respiratory rate is dropping, my darlings, means you are not using up the glucose that you are eating to give you energy. So these people will be lethargic or fatigued easily because they're not getting the energy from their glucose. And secondly, because they're not using the glucose to give them energy, that glucose is converted to glycogen and fat, which leads to an increase in your body mass. And that is why these people, they say, tend to put on weight. I'd like to think I have a lack of thyroxine, but unfortunately it's not. It's just my fantastic eating ability. Okay, so your thyroid gland regulates your metabolic rate. So if your metabolic rate is going haywire, of course, this information is fed back to the master gland, pituitary, and it will start making adjustments. We'll talk about that just now. I just want to mention the second function is that it's needed for the correct functioning of your nervous system, my darlings, and your heart. And the heart, very often we tend to leave out this function, but it's also important for that. So one, it regulates your metabolic rate, and secondly, for the correct functioning of your heart and your nervous system. So let's go back to its role in regulating your metabolic rate. Let's go back to that role. And when we're going back to that role, we'll be talking about something very important. I'll just use this page here. It makes sense, isn't that so? You should have told me that earlier. Negative feedback mechanism, which is the backbone of homeostasis. Homeostasis, or keeping your internal environment constant. You are not aware of what your body is doing right now to make sure that the environment that the cells are having is constant. Or if it changes, it just changes within narrow limits that does not affect the functioning of your organs. So this system that operates is basically based on a concept called negative feedback mechanism. Negative does not mean bad. Negative here means opposite. Feedback means information is fed back and then you get this system operating. Let's take the relationship between TSH, my darlings, the relationship between TSH, if I can just underline TSH, the relationship between TSH, there we go, let me knock it off, and thyroxine in this negative feedback mechanism. Of course, the relationship is brought about because there's a relationship between the pituitary and the thyroid gland. It's a relationship between the pituitary gland and the thyroid gland. Okay, so let's see what happens if your thyroxine levels are lower than normal. For some reason, it becomes lower than normal. Now, how is your body gonna make this right? You wouldn't even be aware of it, my darling. So I always teach children to remember this like this. So if there's less thyroxine, and the opposite of less would be more, yes. So if there's less thyroxine, of course, the information is fed back to the pituitary. You will write it down. It's there in your theory. And the pituitary now will respond by releasing more TSH into the blood. And this TSH will now travel by the blood to reach the thyroid gland. And when it comes to the thyroid gland, what will it do? It will stimulate, isn't that so? It will stimulate the thyroid gland. This is as fast as I can type. To secrete, you tell me now, more thyroxine, producing the opposite response of what we started. So you started off with less thyroxine. So now you're producing, there's my fantastic spelling, you are now producing more thyroxine. So, and when you're producing more thyroxine, what is going to happen? It raises the thyroxine levels to normal. There we go. This is your typical negative feedback mechanism. So I teach children to remember it like this here. Always, my babies, we don't want to do a stamp, always, my darlings, if there's less thyroxine, then there'll be more of that controlling hormone. Always, and then you go that the thyroid gland will secrete more thyroxine until you raise the thyroxine levels to normal. So you must say, sorry, there, I forgot to write down here, raises the thyroxine levels to normal. So less, more, and getting back to normal. That is all you have to talk about in a negative feedback mechanism. And you'll see I will employ this particular explanation for just about every mechanism that you have in controlling your hormone levels inside of your body. Is that okay? So once again, as a recap, pituitary gland produces 4 hormones. You remember it has 4 H's and a P. Oh my God, where's the P? So which is the P, my darling? The P stands for the hormone called prolactin, which is released when a lady has delivered a baby and makes available the milk to the papa. So there we go. 4 H's, FSH, LH, TSH, GH, and prolactin. Thyroid gland produces only one hormone, thyroxine, very important because it regulates your metabolic rate. Okay. So I need one thing to remember, darling. I can't make a mnemonic out of that. Thyroid, thyroxine. Pancreas, you've already learned about this, isn't it? So when did you learn about it? You learned about it in grade 11. It produces the hormones insulin and glucagon. I keep saying glucagon, hoping that children will remember how to spell it and not confuse it with that stored glucose molecule called glycogen. How do you remember pancreas produces insulin and glucagon? I thought you'd remember it by now, but I've got a mnemonic by which you remember it in case you get confused. There's it. You're never going to forget this one. P. Pancreas produces insulin and glucagon. Okay, so once again, my darling, these 2 hormones control your glucose levels. I'm repeating from grade 11. They control your glucose levels. And they are opposite in action. So whilst insulin will decrease your blood glucose levels, glucagon will increase it. And it stands to reason they're never going to be produced at the same time because they are opposite in action. So you have to state how insulin decreases the blood glucose level. By the way, when will you have to decrease your blood glucose levels, darling? Yes, after a meal rich in carbohydrates, because from carbohydrate digestion, you produce glucose. And this glucose, my darlings, will heighten your blood glucose level, and you want the glucose to move out of the blood and get into the cells. So here's your negative feedback mechanism. Let's deal with your negative feedback mechanism with glucose. Let's deal with that. And you find that when you have your blood glucose levels high, so increased blood glucose levels, and I like to repeat, normally after a meal rich in carbohydrates. So increased blood glucose levels. So where will you find it detected? By the way, with your increased thyroxine levels, who detected it? Pituitary. So the receptors were in the pituitary. Remember, the spies are the receptors. So increased blood glucose levels, who will detect it? Will be detected by your, what do you think? Yes, by the pancreas. And the pancreas becomes aware that there's high blood glucose levels, and what's it going to do? It will now release insulin into the blood, and this insulin travels in the blood and it decreases the blood glucose levels by stimulating the absorption of glucose by the cells. So once the cells absorb the glucose, cells are out of the blood, so that means the glucose will go out of the blood. And secondly, it stimulates the conversion of glucose into glycogen in the liver and muscle cells. Remember, liver and muscles have stored glycogen. Okay, so that's how it does it. So that's your negative feedback mechanism with your increased blood glucose levels. So, papas, what would happen if you have decreased blood glucose levels? You should know this by now. Decreased blood glucose levels, of course, that would be once again detected by your pancreas. I'm not going to repeat that. And in essence, what is the pancreas going to release? The pancreas is going to release into the blood. You're going to tell me while I'm doing my fantastic typing? Into the blood is going to release glucagon. No, that's a hormone that will now go target your liver and muscles and cause the conversion of glycogen back into glucose. That glucose will enter into the blood and become available to the cells again. That raises your blood glucose level. So whilst insulin decreases your blood glucose level, glucagon raises your blood glucose level. There we go. Pig pancreas produces insulin and glucagon. And everything to do with diabetes, you'll have to know, papas, because if you have a lack of insulin, you have that condition called diabetes. Symptoms will be thirst, frequent urination, fatigued all the time, loss of body mass. Those are some of the things that you would experience if you are diabetic and they ask you to eat a meal that is low in carbs, a meal designed for diabetics. You drop your carbs in your meals, and of course you will take medication, right? And then we come to adrenal. Let me do adrenal by taking off all these distracting things. Okay, let's do the adrenal gland. Now the adrenal gland, babies, actually produces two hormones. Let's do the first one, the one which is called the fight or flight hormone, adrenaline. Do you know what you would do if you are exposed to a dangerous situation? My darlings, you'll only know when you're exposed. And God forbid that you are ever exposed to a situation that threatens your life. But adrenaline prepares you for that emergency in various ways. But what I want you to understand, darlings, the basic reason why adrenaline is released is to cause the increase of glucose and oxygen available to your cells. Now, if you understand this here, then you would understand increased. What is that there? It's supposed to be availability. yeah, of glucose and oxygen to the cells. Now, if you understand this concept, then you would be able to understand the functions formed by adrenaline. How is oxygen and glucose made available using adrenaline? But please, you've got to understand this first, and then the rest of it will make sense. By the way, you've got to understand why glucose and oxygen too, isn't that so? Because glucose and oxygen, why? As glucose and oxygen are needed for, you tell me, you learned about this even in as young as grade 8, are needed for respiration. And why you want respiration? Because through respiration, what are you going to be getting? The energy that you need for an emergency situation. There we go. So if you understand why adrenaline is produced, then you'd be able to logically understand the functions performed by adrenaline. A very famous question in examination as well, my darling. So know the functions of adrenaline. Or must I repeat, you must know the functions of everything. Okay? You must know your theory. You cannot apply your theory if you don't apply your theory, if you don't know your theory. Okay? So how do we remember this? I teach children this mnemonic. He can buy, sorry. He can buy goat's milk. Who's he? I don't know. But he can buy goat's milk too. This is the way in which you remember the functions performed by adrenaline. So he's standing for it. Let's do it. And please try and remember this. This is a mnemonic. You can write it down separately. It increases your heart rate and your BP. What's BP? Blood pressure. Now, the reason why it increases your heart rate is that you want the blood to flow faster to your cells because it will be carrying glucose and oxygen to the cells. Blood pressure will also help in moving the blood faster to the cells. Okay, I'll come back to the C. B, what does it do? It increases your rate and depth of breathing. Your rate and depth of breathing. So that means you are breathing faster and breathing deeper. You breathe faster to get in the oxygen quickly and get out the CO2 quickly. You breathe deeper to get as much oxygen as possible into your body. You just don't want the normal amount of oxygen. You want to increase the air coming into your system. Goats, here we go. It can convert glycogen to glucose. Who else can do that? We just learned about the other guy who can do it. Who is it? Glucagon. Glucagon can do the same. So both adrenaline, let me just do something. Both adrenaline and glucagon can convert, what is it? Glycogen to glucose. There we go. And therefore it makes that glucose available. It makes the glucose available. I see, sorry, my darlings. It makes the glucose available for the process of respiration. Okay. And then I think I got a bit of problem here with this milk one. Let's go to the milk. So what does the milk stand for? The M stands for, it increases, my darlings, increases your metabolic rate. Here we go. Increases the metabolic rate. Now, what did I say? You must take metabolic rate to be your respiratory rate. So if it increases the metabolic rate, means it's increasing the rate of respiration, thus increasing the production of energy. How's that so far? And the last one, T, 2, it increases muscle tone or the readiness of your muscles to act. Some of you may just run faster than your legs could carry you. That is because of your increased muscle tone. The reason why I'm coming back to this one, CAM, is that very often in the examination, they ask this for 4 marks as an explanation. You know, which are some of the ways in which it makes your glucose and oxygen more available to your muscles and your brain, for action. And that is because the C stands for, not because the C stands for, but this is how you remember it it constricts or narrows your blood vessels to your gut and your skin. So if it constricts it to your gut and your skin, that means less blood is going to your gut and your skin. That is why many people, when they are frightened, they look very pale, because there's less blood going to your gut and your skin. So what's happening to this blood if less blood is going there? Where will more blood go to? So more blood is shunted. They use the word shunted, hey? Is shunted. More blood is shunted to the muscles, because those are the organs of activity here, and your brain especially, okay? Muscles and the brain. Oh, look at my shunted, my darling. That is not a new English word. I sometimes think I can create my own dictionary. More blood is shunted to the muscles and the brain to provide them with more glucose and oxygen that will be used for the production of energy. There we go. So it constricts blood vessels to gut and skin, you got to say, thus less blood will go to the blood to gut and skin. And, oh, mommy, I forgot about something. It dilates the blood vessels to the muscles and brain so that more blood is shunted to the muscles and brain, carrying your glucose and oxygen. How's that? Okay, so please go to your theory and learn it like that. So 2 marks were saying it constricts blood vessels to the gut and skin. Therefore, less blood will go to the gut and skin. It dilates blood vessels to the brain and muscles, causing more blood to go to the brain and muscles. And carried in the blood would be glucose and oxygen, which will be used during the process of respiration to provide huge amounts of energy. You are just not providing energy, you are producing large amounts of energy. And that is how you remember the functions of adrenaline. He can buy, not breathing, he can buy goat's milk too. Write down these mnemonics if you are not taught by me, and it's an excellent way of remembering your work. So let's go to the other hormone produced by your adrenal gland, my darlings. And the other hormone produced by it is the hormone called aldosterone. And I don't know why examiners like to ask this of you in a 1-mark question or a 2-mark question. So don't think you'll ignore aldosterone because you think adrenaline is going to save you. Aldosterone will save you too from having too much of salt in your body. So what it does, my darlings, it regulates your salt levels. Regulates salt levels. Now, how is it able to do that? Of course, the organ that is involved in controlling salt levels is your kidney. So that means that aldosterone, its target is the kidney. Its target organ is the kidney, because that's where its action is. And in the kidney, there are tubules of the kidney. So what it does, let's take a situation where you have less salt in your body. Now, if there's less salt in your body, of course, you'll have cramping, etc. in your body, isn't that so? So the changes happen in your body without you even knowing it. So what did I say to you? If you have less of something, how does your body now make this right, my darling? If there's less salt, you go with the opposite, isn't that so? What is the opposite of less, my darlings? Now, more aldosterone will be produced, because that is the hormone. More aldosterone will be produced, causing the tubules to absorb more salt is absorbed from the kidney tubules, because you know your target organ is your kidney, from your kidney tubules into your blood. You gotta say into your blood, because where is it going to be absorbed into? Because you want the salt levels to increase in your blood. So more salt is absorbed from, we use the word reabsorbed, isn't that so? Because it was absorbed at first. Sis, my darlings, it was sis, no, nothing's happening. Remember, the word is reabsorbed. Oh, there we go, we got it. More salt is reabsorbed from it was first absorbed, sorry, babies, train of thought. It was first absorbed in your digestive system. Now it is being reabsorbed from the kidney tubules back into your blood. And this will now, what is the consequence? Sis, sorry about all these exclamations. This will now raise the salt levels to normal. How's that? So it's the same thing. So if there's less salt, less salt it was supposed to be, sorry, more aldosterone released, more salt is reabsorbed, so less, more, and then rising to normal. Negative feedback. So let's take the other one. If there's lot of salt, then you go less aldosterone is released from where? From the adrenal gland. Less salt is reabsorbed from the kidney tubules back into the blood, dropping your salt levels to normal. Yet another negative feedback mechanism. So we did the negative feedback mechanism, darlings, between TSH and thyroxine. We did it regarding your glucose levels. We did it regarding your salt levels. And two more you have to know with your negative feedback mechanism to complete this section on homeostasis and hormones. Notice it wasn't too difficult, was it? So the other hormone is released by a gland to which the pituitary is attached. It's also part of your brain. Any part of your body that produces a secretion is called a gland as well. It's also called a gland. So which part of the brain is your pituitary attached to? That area over there, my darlings. That area over there is called your hypothalamus. Remember? How did you remember the function of hypothalamus? Yeah, it controls thirst, appetite, taste, P. T-A-S-T-E-P, thirst, appetite, sleep, temperature, emotions, and blood pressure. So the hypothalamus, my darling, blood pressure is actually affected by the amount of water that is found in your blood. The amount of water is found in your blood. So if you find that you got too much of water, baby, then the hypothalamus will have to make adjustments to bring your water level down to normal. And how does the hypothalamus do that? By releasing a hormone called ADH. Now you've already come across this. That is why I've left this to the end. ADH, isn't that so? Oh no, ADH is in caps. It is an acceptable abbreviation. You don't have to know it stands for anti-diuretic hormone, ADH. And dear darlings, ADH now, once again, its target organ is your kidney. Here, specifically, you're collecting tubules or you're collecting ducts in your kidney. All right? So from here, it will travel right down to your kidney. Aldosterone had an easy ride just from there to there. But here, from there to there, via the blood, it comes down to the kidney. So how does it affect changes? If there's less water in your blood, of course, the hypothalamus becomes aware of it because it's got receptors. So the receptors are found in the hypothalamus. It picks up as the blood is going to the brain. Hypothalamus becomes aware, oh my God, there's too less water in our body. Let me do something about it. So if there's less water, what we go with opposite of less, my darlings, more ADH is released from the hypothalamus. And this will cause your collecting ducts or collecting tubules in your kidney. Please say in your kidney because you know your target organ, your kidney. Collecting tubules in your kidney, to become more permeable. To become more permeable. So forgive my dogs, my darling. Become more permeable. More permeable means become more holy. Now this is not the H-O-L-Y. Holy means having more holes. Okay, that's our word. So that more water will move out. So more water moves out of the tubule. More water moves out of the tubule. Out of the tubule. You know, by osmosis, isn't that so? They don't, moves out of the tubule and is reabsorbed. You must say this. And it is reabsorbed back into the blood. Back into the blood. So what would be my final statement? So we went with, here we go. We went with less water, yeah, less, more, more, more. And what should be my final statement? What should be my final statement? What do you think? Have you thought about it? And is reabsorbed back into the blood, raising the water levels to normal. There we go. That's how you remember what happens in the negative feedback mechanism when there's less water. Of course, you'll do the opposite if there's a lot of water in the blood. It's the information your hypothalamus becomes aware. By the way, those receptors in the hypothalamus to do with detecting water are called osmoreceptors, from the word osmosis, osmoreceptors, O-S-M-O. So osmoreceptors in the hypothalamus become aware. And now if there's lot water, less ADH is released into the blood, collecting ducts become less permeable, less water moves out of the tubule, and less water is reabsorbed back into the blood, dropping the water levels to normal. Because if less water goes out of the tubule, means more water will remain in the urine, so you pass out loads of urine. By the way, this is what happens when people have alcohol as well. Yeah. When people have alcohol, they tend to water all the plants on the highway, on the sides of the highway. That is because alcohol has a way of suppressing your hypothalamus. In other words, when you have alcohol, you produce less ADH. And if there's less ADH, then your collecting tubules become less permeable to water, less water moves out, and less water is reabsorbed into the blood, and more water passes out in the urine. That is why when people drink, they produce loads of urine. There we go. And the last one, my darlings, that you have to know, notice I'm giving you a lot of theory and I'm giving you to quite fast because I want to focus on how to remember it, the theory you have got in your notes. And the last one is the control of CO2. Of course, you also did this in, when did you do this, babies? In grade 11, carbon dioxide levels. I'm sure you learned it off by heart there because carbon dioxide is normally produced when you do strenuous exercise, something that I'm not used to. Okay, why would you produce loads of carbon dioxide? Because your respiratory rate is high when you're doing exercise to give you the energy for exercise. So this carbon dioxide accumulates in the blood, and carbon dioxide is poisonous. And so this information is fed back to who? The medulla oblongata. And who are the spies who tell the medulla oblongata there? There are special receptors that are found in your blood vessels in your neck, called the carotid arteries, C-A-R-O-T-I-D. Those receptors now pick up that there's a raised CO2 level. Impulses are created, taken to the medulla oblongata because it controls involuntary actions, that which you don't have conscious control over. And the medulla oblongata says, oh my God, I got to rectify this. And it sends impulses to the heart, and the heart beats faster, you know, to send the blood faster to the lungs so that you can get the CO2 diffusing out of the blood and then you breathe it out, okay? And it sends impulses to your breathing muscles so you start breathing faster and deeper. So those are the mechanisms that are involved in dropping your CO2 levels to normal. With that, my darlings, we have successfully completed within a short period of time chemical coordination, by far the major part of it, chemical coordination and the negative feedback mechanisms. I will just do this one question here, and then when I meet you in the next video, we will do the rest of the questions. We've done label the parts 1 to 4. Look at the second question. Write down only the number of the gland that produces the hormone glucagon. How did we remember it? We remember it as pig. So it's the pancreas. Produces a hormone that controls the growth of long bones. Even if you didn't know it was long bones, your teacher would have told you bone, skeleton. No. So it will be your pituitary. They don't want to know the name of the hormone. They want to know the name of the gland. That produces an iodine-containing hormone. Oh my God, you learned this in grade 10, isn't that so? That thyroxine needs iodine for its production when you learned about micronutrients in grade 10. You don't have to keep your grade 10 notebook. No, my darlings. Just that one fact or so you would have carried with you. I wonder if you did. So that one would be the thyroid gland. Number 2. Oh, by the way, this answer here is number 1. That answer there is number 3 because they asked you for the number only. Produces a hormone that's involved in the reabsorption of some salts in the kidney. We just did it. That is number 4. The hormone was aldosterone. State 2 similarities between hormones and nerves with regard to their function. Similarities is that, both of them sense changes in the environment. Both of them sense changes in the environment, whether it's the external or internal environment. And both of them provide a reaction to these stimuli that you have received. Remember, a change in the environment is known as a stimulus. State 1 functional difference between hormones and motor nerves. You find that hormones, the response is generally slow. With motor nerves, the response is generally rapid. With that, we bring an end to this part of your video on chemical coordination. When I do see you next, I hope that you have gone through the rest of the questions on chemical coordination and you would be more able to work with me through these questions. So, my darlings, God bless, and I will see you soon.